Hello friends, here in this video we are going to discuss what is meant by memory representation of one-dimensional array. Now till now in previous videos we discussed what is meant by array and what are the types of the array, and we already discussed the one-dimensional array in previous video but with the example. Now here we are going to discuss how memory is going to represent in one-dimensional array, what is meant by addressing, what is meant by indexing, and here we are going to apply one formula to calculate the address of particular element which is present in one-dimensional array at a particular index. So here we are going to understand addressing, indexing, and how to find out or how memory is representation, what is meant by base address, and how we are going to find out the address of particular element. So let's start. So here let's first understand what is meant by array. Now here in this diagram you can see array is nothing but collection of element of the same type, and it's stored in the continuous manner. Now here you can see it's stored in continuous manner. It's an block. This is the first index of 0. Now total length is nothing but the 10 from 0 to 9, and this is called as the indices. Now we know that array's first element is always stored with the 0. That's why it is from 0 to 9 and total 10 element is present. Now here array is nothing but the collection of element with the same data type and which is continuous memory location. Now why it is a single or why it is called as a one dimensional? Now because you see this is a single row exists in one dimensional array, that's why it is nothing, it becomes a one dimensional, and every element is accessible by the index. Now it can be accessed by this indexing. Like if I want to random element from this array, I can choose the index 4, 6, 8, 9, 1, 2, etc. Now let's understand how memory allocation for one dimensional array or addressing and what is meant by indexing. Now here you can see this is the A of 0. These are called as the indices. These are the element which we are going to store at that particular position or index, that is 5, 7, 2, 12. Now memory of an array is allocated in the continuous manner, and the address of the ith element. Now what is meant by I is nothing but the index, like 0, 1, 2. Now all this address, that is second position, is at the address of 1004. So how we are going to calculate by the base address? Now here what is meant by base address? The address which is always started, that is now array is always started with the A of 0, that is this is the first element. So and 1000 becomes the base element because it's started with firstly started with the A of 0 and address is the 1000. So it becomes the base address. Now base address and element of the size. Now what is meant by element size? Now here it depends on the data type, that is type. Now here you can say this is the data type integer. So each element of the integer array will takes 2 bytes of memory. That's why we address like 1000, then it occupy the 2 bytes for the first element. Second element of 1 occupy the again 2 bytes, that is 1002, 1004, and so on. Now let's understand how we are going to find it by the formula, or how we are going to find out the address of particular element. Now here let's consider A of 2. Now A of 2 is nothing but, that is I am not talking about the second element, that is second element is the 2, but we are not talking about the element here. We are talking about the element which is located at the second position, or which is located at the second element, that is this is the second position, or you can consider it as a position. Now let's first understand what is meant by, we know that already what is the base address. Now base address is nothing but the first address of the element. Now here in this case the first address is the 1000. Now let's consider element which is occupy or each the size of each element is a 2 byte, because this is the data type as a 2. Now it's vary or it depend upon your computer. As it is an integer, so here we are going to consider as a 2 byte in the memory. Now let's understand a of 2. Now 2 is nothing but the index is equal to 1000. 1000 is nothing but the base address plus 2 is nothing but the weight. That is the each element is occupied the 2 bytes in the memory. Multiplication 2 is nothing but the indices, that is the position of that particular array which will go into the address of a of 2 minus 0. 0 that is nothing but the started indexing or started address indexing. Now this is 1000 plus 2 into 2, that is it becomes the 4 and we'll get 1004. So address of 2 or position of the 2 is at the memory address 1004. So we'll get this memory address by using this formula. So let's understand this with. So let's derive the formula to find out the address of particular index. So a of I is the index, then B is nothing but the base address, I is the element index, B is nothing but the base address. Now here in this case base address is the 1000. Now this W is nothing but the storage of the element stored in any array in byte. Like here the storage data element is a 2 byte. So difference of this element is the 2 bytes. And LB is nothing but, now here I is nothing but the element index only, and LB is nothing but the lower limit, lower bound. Now here lower limit a of 0 and upper bound is the a of n. So at the starting index is always is 0 because it's an array, and if not specify assume 0, but by default array is always started with the 0. So lower bound is always 0. So this is all about the formula which we can derive by to find out the address of particular indices. Let's solve one more example. Suppose I want to find out the address of a of 1. If I apply the same formula, now here B is nothing but a base address. Now base address is 1000 plus W is nothing but the weight. Now here the each element is the 2 byte. Multiplication into bracket we have to write index, that is we have to find a of 1. So here we write 1 minus lower bound is always 0 or started with the 0. So here we'll get the result like this, and the total a of 1 is nothing but the 1000 plus 2, so it becomes 1002. Now in this diagram you can see a of 1 is to 1002. So this way we can find the address of particular index, or we can find out address of particular element if we know the index. Thank you.